This is a crazy question. It's just very unusual. It's not that it's like crazy hard, but because there are very few difficult probability or statistics questions on the practice tests, you are probably not going to feel prepared if you get a difficult probability or statistics question on your real SAT. You just aren't seeing very many of these questions. So that's why this might be a good question to skip if you're worried about running out of time on the math modules, because yeah, it's going to take you a lot of time to figure it out, whereas there might be technically harder questions later, but because they might be about topics you're more familiar with, like the number of solutions or the circle equation or quadratics or something, you might just be like, okay, it's hard, but I've at least seen something like this before. I kind of know how to work through it. So here, use your judgment. If you look at this and you're like, oh my God, this is crazy, I've never seen anything like this before, mark it for review, pick a random letter, and come back later. That's fine. But obviously, I'm going to show you how to do it now, so that way we do know how to deal with something like this in the future. The fact that there are so many numbers tells me that this is really a question about organization. So let's see if we can organize this. A grove has 6 rows of birch trees and 5 rows of maple trees. Okay, so we have maple, we have birch, we have the number of rows, and we have 6 rows of birch. I don't know why I put it backwards, but that's okay. Each row of birch trees, actually it's bothering me that it's backwards. Why? See, this is a good example of like, sense the fact that you're going to make a mistake and do work that's going to prevent it. Each row of birch trees has 8 trees 20 feet or taller. So greater than or equal to 20 feet. So that is going to be for birch, that's going to be 8. And 6 trees shorter, so less than 20. So that's 6. Each row of maple trees has 9 trees 20 feet or taller and 7 trees shorter than 20 feet. A tree from one of these rows will be selected at random. What is the probability of selecting a maple tree given that the tree is 20 feet or taller? So this word should trigger something for you. Not only are we dealing with probability, but we are dealing with conditional probability. And that is going to mean that when we make this chart, we've got some issues. It's going to be complicated. We have to make sure we're looking at the right thing. So I would actually start with that. Given that the tree is 20 feet or taller. So I'm only interested in this part of my chart for now, right? So I don't care about the trees that are smaller. We're being asked, basically for every probability question, we need to make a fraction. So the bottom of our fraction is going to be the number of trees that are 20 feet or taller. It is not going to include the small trees, okay? So you might be thinking, oh, it's 17, right? 8 plus 9. But no, we have to recognize that for each row, there are 8 of the big birch trees and 9 of the big maple trees. So we have to multiply. So what's really happening here is we have, where can I put this? Let's put it here. 6 times 8 is 48 and 5 times 9 is 45. So how many actual trees are we dealing with here? 48 plus 45 is 93. 48 plus 45 is 93. So that is our kind of denominator. That's the bottom piece. And notice I've kind of ignored half the question here because usually when you mess up on conditional probability, it's right there. It's that bottom. You're just kind of used to thinking about totals. You really want to include all the trees because why did they give you all this information about all the trees? But that's kind of the point. Conditional probability is forcing you to use only part of the data. So it's up to you to use the right part. Now we can go to the top part. What is the probability of selecting a maple tree? Well, there's 45 maple trees. So it's 45 out of 93. Now that's not an answer, but that's okay. We can divide. I'm assuming that everything is divisible by 3 here. So 45 divided by 3 is 15, and 93 divided by 3 is 31, and 15 out of 31 is an answer, and that is the answer. So at the end of the day, there's really not much math we had to do, right? We had to multiply some things, we had to create a fraction and reduce it. So the math itself is not hard. But with probability, especially conditional probability, the real challenge of the question is much more about reading carefully and following the correct instructions. So I kind of knew that right away. That's why I immediately started making a chart here, is I knew that this was going to be about organization. And so you've got scratch paper, right? You got to use it. This is a great example of like the people who have the most trouble with this question are the stubborn people who for some reason think that they can do all the math in their head. No, don't be that person. That's dumb. So put it on the page, get it out there, see it, understand how all this data relates, and hopefully you'll be able to understand what the question is asking more clearly because you don't have to hold all the information in your head and understand the question at the same time. The information gets on the page, so you don't have to have it in your head. Make room for new ideas in your brain, and new ideas will come, and more problems will get solved.